Hello everyone, I'm Yuqing Zhao from protocol testing team, and my presentation will introduce bring your own device protocol test suites. This is my agenda. Firstly, I will introduce the BYD protocols and how we design the tests, and then I will introduce how to use our test suites. As you know now, bring your own device is a bigger concept. It allows employees to bring personal devices into the work. So it contains multiple system areas. For example, we have already in previous session, we know that we have workspace join to register a device, and it's similar like traditional domain join. And we have file sync to synchronize personal work files from company internal network. And also, I will cover the protocols and the related test suites for these two areas. And also, we'll introduce another two areas later. Firstly, I will introduce our protocols of workspace join and the related test suites. Let's see how the traditional domain join works. The traditional domain join is like a client machine use RPC and or LDAP protocol to create an active directory machine object on the domain controller. It will create attribute like SM account name to be the unique attribute in the global domain, and also set the trust password. So when the client performs authentication, it will use the trust password to present its identity. And for the workspace join scenario, it's like that the personal device will use HTTP and as HTTPS as transport protocol, and use XML or JSON schema as the HTTP message body. And when the user has authenticated, the AWS service, the workspace join server side will issue a device certificate associated with the user. So, because that it will be used to present that who the device belongs to, and when the device should use this certificate in the SSL client authentication to print its identity, so that the AWS server will know, will recognize the device and know the user is using his own device to access the web resource. We have three protocols for the workspace join scenario. First one is MS DVRD. DVRD. This is a discovery protocol where it tells the client side which authentication endpoints it should contact and which endpoint it should contact to enroll the certificate. And also we have a MS OAPS protocol. It has extended the popular OAuth 2 protocol to allow the user to be authenticated during this scenario. And we have another protocol, MS DVRE. This is a protocol to actually enroll certificates. Now let's see the protocol stack of these protocols. For the DVRD, this is only based on the HTTPS transport. And for the OAPS protocol, it just extends OAuth 2 protocol. And then it also uses HTTPS as transport. The DVRE protocol is actually based on extend the WS trust protocol. It uses its data structure to transmit the certificate on the wire. It uses HTTPS as transport too. Now let's see how the workspace join scenario works on the wire. Firstly, the person device should contact discovery endpoint to find out which endpoints it should use. The next step is called authorization. The device should contact two OAPX endpoints to authenticate the user and grant access token. The last step is the device contact the enrollment endpoint so that it will get a certificate, device certificate. And it should save this certificate to a private data local storage because it will be used to present the device identity. If you share this device certificate to another device, it means that device has duplicate with the original one. This is how the protocol message sequence on the wire. Next, let's see how we design the test. Firstly, we have choose the client-side implementation of this workspace join scenario, which means we will test the client roles of DVRD, DVRE, and OAPS protocols. For the test methodology and environment is that we have developed a synthetic server test suite. The test suite will act like a server to return response message to control the device side state and compare with expected state. If they don't match, we will return a verification error message and fail the test case. And the test environment is very simple. We just need we have two machines. One is test suite machine to host the test suite. Another machine is your device implementation. We just need to plug these two machines into same network, and then we can start the testing. This is about workspace join testing. Next one is I will introduce the file sync. It's also called the enterprise client sync or work folders. And this is already covered by in previous presentation, so it will be very quick. We have two protocols, MS ECS to upload and download file on the wire, and also another protocol, MS FSVC from Microsoft Sync Framework to present the algorithm and data structure to compare file version. For a protocol sequence on the wire, we have two scenarios, and upload and download. So both of them have three steps. The first step is the client side should create a session with the server side, and it should determine the session is used for upload or download purpose. If the session is used for upload, the client side should get server side file versions to see that whether the files on the server side is newer than the local one. If it is, it should be try to resolve the conflict on the client local device, and then upload the files. If the session is used for download purpose only, the client side should send the client versions to the server. And the server, after comparison, will return a return code. If it says files on the server side are already latest, is newer than the client side, then client side should download the files. If both sides have same versions, then client can just stop here. This is how the file sync scenario works for the protocol perspective. And I will tell you how we design the test then. For the testing, we have choose the client role for the testing. Our test suite will cover the client roles of MS ECS, and also we will use MS FSVCA during the testing to verify that your device implementation has correctly set the fields of those data structure. Our test methodology is similar to the workplace join scenario, and we use a synthetic server to talk with the real file sync client side. And our test suite will support the manual deployment way, which means you need to type in the URL into your device and then start the testing. And we will currently we don't support ADFS authentication yet, so we major focus on the testing the MS ECS message on the wire, and in the future we will support that. This is how we test the file sync scenario. So now I will introduce another two BYOD protocol areas. These are not covered before. First one is about the web proxy. This is a standard network topology diagram represent how the web proxy placed. This is similar to the common usual called reverse proxy placed at the edge of the corporate network, and it will use to protect backend ADFS and web application server. And the difference is that Microsoft Web App Proxy will do some pre-authentication, and it only allows authenticated network traffic goes to the web application, so that even to protect the secret, improve the security of the whole environment. And the related protocol for web proxy is called MS ADFS PIP. This is a protocol to describe integrated system of ADFS and the web proxy. The proxy, this protocol on the wire is very simple. It's just based on the HTTPS and use JSON as HTTP body. But for when you implement that, you have to involve this protocol like WS Federation, MS OAPX, and CMO, because the web proxy should need to pass the security token in the traffic to recognize that the client side is authenticated or not. And it also should be able to sync the metadata from the ADFS. For the web for this integrated system, we have three scenarios. First one is we will deploy how we deploy the web app proxy. It means how the proxy will register its info into the ADFS database. Only after it's registered, ADFS will talk with it. The second scenario is that we will how the web application is published, because for this scenario is that we will set some published information on the ADFS database, so that the proxy will know which application can be accessed via outside network. And also we can remove the published information for the management purpose. The last scenario is called pre-authentication. This is a web proxy will always redirect unauthenticated user requests to the ADFS server to make sure the security of the web application. This is the three protocol scenarios of web proxy. For our testing, we have choose web app proxy as our SOT. So you can simply replace your implementation with that into this position, and talk with ADFS server and web application. Our test methodology is that we have developed a synthetic ADFS server and also to talk with your proxy implementation, and also we have added web client and a web application server into the test suite so that you don't need to deploy a complex environment, just need 2 machines, then you can start the testing. Okay, then I will introduce the last one, last scenario. This is called mobile device management. Let me do a simple introduce for this part. For the mobile device management, currently we have Microsoft implementation as a server side in the cloud called Windows Intune, and it can manage the iPhone, Android phone, and Windows phone. And also, we can't forget that we will use the laptop and Surface device like Surface as a personal device to work. So Windows Intune can also manage the Surface and any laptop running Windows OS, client OS. And for the IT for the admin of the company, they can use the browser to access Windows Intune directly to manage everything. And also, they can use the SCCM to access the management of Intune. And my introduce here will focus on the Windows, how the server side manages Surface and Windows Client OS. We will use 2 protocols in this scenario. First one is MSMDE. It will be used to enroll a mobile device certificate. This certificate will be used to establish the management session and present the device identity. The next protocol is we will use called MSMDM. This is the actual protocol to manage the mobile device, like do something like update a local policy and install a private application. For the protocol stack of them, MSMDE is a SOAP protocol and use HTTP transport because it will involve a step of authentication and may ask you to input the user secret. The MSMDM protocol is based on the OMADM public protocol and use the SyncML as the actual HTTP body to transport the management request and response. And it can use HTTP or HTTPS. And these 2 protocols are protocols on the protocols there on the wire. And for the management, we also need the device schema. Here I have provided a sample of the device side management schema from our protocol document, MSMDM. And this is use managed object format, the MOF format to document that. For the protocol scenarios, we have these scenarios for the management. First is manage the certificate enrollment. This is how the device side enroll a certificate. And also we will test. We can test how the device server side will retrieve the device authentication. This will be used to, for example, you may modify your device owner names, and the server side will know that you have modified that. And also, the server side can tell client side to update a local policy like the lock screen, password legends. Also, as you know that for our cloud strategy, we allow Windows device to install the private application. This is different from the public application because public application will be published in the Microsoft App Store. It will be reviewed by Microsoft side. And for the company private application, it will be published into the service like Windows Intune, and only while with MS MDM protocol, it will the client side will be able to install such private application. Another scenario is we can retire the device from the management so that the device cannot be accessed by the company administrator again. Now let's see how we test this mobile device management scenario. We have chosen the server-side implementation for the testing as SUT, and we will test the server roles of MS-MD and MS-MDM protocols. Our test methodology is that we have write a synthetic client test suite to talk with your server-side implementation. And this test suite will treat the MDAE and MDM implementation as a black box. You just need to type in a different configuration for our test suite, and it will know which endpoint it will use for the MDE testing, which endpoint it will use for the MDM testing. It does not need to know whether your implementation is one machine or two machines. And also, if you have put your implementation to the cloud side, our test suite can interrupt with it still. Now let's see how you can use our protocol test suite to test whole BYOD scenarios. Firstly, you will need to follow the user guide for the deployment. Our user guide has documented the steps you're required to configure your implementation for the testing, and also will provide steps to how to configure Windows SUT for your as this example. And then you need to fill the test suite configuration file based on the configuration comments or the user guide. Then you can run the test suite. You can use Visual Studio 2012 to run test suite, or you can also use the batch file. But for the BYD test suites, I recommend that you use the Visual Studio to run, because you don't need to open the File Explorer and find out the test result and see why the test case failed. You can just directly click the link in the Visual Studio to open it. Later, then you can analyze the test log. Our test log will log every step of the test cases and the detailed assessment whether the data structure matches protocol documents. And also, for the error message, will include protocol document session numbers so that you can quickly find out related statements in the document. Okay, this is my introducing for the BYOD test suites. Any question? Okay, thank you.
Thank you, Yuqing.